In this video, we will look at how to use the logarithm rule for integration. Recall that your derivative of the natural log of x is 1 over x. In general, the derivative of the natural log of u is the derivative of u divided by u. So that gives us the following rules for integration. If we have a differentiable function of x, then the integral of 1 over x dx is the natural log of the absolute value of x. And again, in general, the integral of 1 over u du is the natural log of the absolute value of u. So the tricky part is, usually you have to make sure, of course, you have that du. So let's look at these first examples. We have a fraction where we have our variable in the denominator. So if I let u equal to 5 minus 4x, then du would be negative 4 dx. And solving for dx, we would have that. So this integral now becomes 9 over u times negative 1/4 du. Here's our u. That goes down here. 9 is just a constant, and of course we could pull that to the outside, and then negative 1/4 du takes the place of dx. So we would integrate this and say, okay, this is negative 9/4, those are our constants, natural log of the absolute value of u plus c. So negative 9/4 times the natural log of 5 minus 4x plus c. So trying to get it into that format of 1 over u du. Let's look at number 2. Again, we have that fraction. The higher degree is on the bottom, so let's try that u substitution. That's looking pretty good because I have x squared dx, so I just need to isolate that x squared dx. So this now becomes 1/3 du times 1 over u. Here's our u, and this part is x squared dx. So integrating that, that's 1/3 times the natural log of the absolute value of u plus c, and then substituting back what u was equal to. So it's a very easy integration. You just have to make sure you have that du part. Let's look at a few more examples. Trig. Now that looks weird, and who likes cosecant? I'm not a big fan, but let's just plot ahead. If I let u equal to the cotangent of x, do you remember what the derivative of the cotangent is? It's negative cosecant squared x dx. Pretty good, except for a negative sign. And so this integral is negative du over u. So that's negative natural log of u, and then we have cotangent. Could you have gone about that problem a different way and ended up with the same answer? Maybe. Maybe you could have changed it to sines and cosine. I'm not too sure, but that seems to be the easiest way to work that problem. Now looking at number 4, that's different. We have a much higher exponent on top than on the bottom. What do we have to do? It's definitely not going to be du over u. Well, this is what's called an improper fraction. So before I start trying to integrate, I need to change that to a proper fraction by using long division. So let's see, x divides into there 2x, then I multiply, I need to subtract, then divide again, subtract, and I have a remainder of 19, which goes over my divisor. So this integral now becomes the integral of 2x plus 11 plus 19 over x minus 2 dx. So I could rewrite that as really 3 separate integrals. I could have integrate 2x dx, which is easy, the integral of 11 dx, and then I have the integral of 19 over x minus 2. And this is the one that's going to come into the natural log rule because now I have a constant over just x to the first degree. So this integrates as 2 times x squared over 2. This integrates to 11x, and then if I let u equal to x minus 2, then du is dx. So I'm pulling out the 19, natural log of x minus 2 plus c. So really, there is your final answer. So let's practice that long division again. It's needed because we have an improper fraction. Okay, so dividing the first two terms, multiplying by x, so that's x cubed, and that's minus 5x. So again, subtracting, I have negative 4x squared plus x plus 20. So now we need to multiply by negative 4 and subtract. And so I have a remainder of x over x squared minus 5. So now I have this integral of x minus 4 plus x over x squared minus 5 dx. So just like on the last example, we can separate that. So I'm going to integrate x, that's x squared over 2. Integrate negative 4, that's negative 4x. Now I have x over x squared minus 5. So if I let u equal to x squared minus 5, du would be 2x dx. So moving the 2 to the other side, hopefully you can see that that's a 1/2 du over u. So 1/2 times the natural log of u. Don't forget those absolute value signs. Now number 6, that just looks kind of scary. What can we do? Well, so far we do not know how to integrate the natural log of x. We can take the derivative but not the integral. So what is this? Not sure. Let's look at the natural log of x cubed. What could that be the same as? Well, believe it or not, with rules of logarithms, we can take a power and move it down in front. So this integral could be written as 3 times the natural log of x times x. Does that help? I don't know. So how about let's let u equal to the natural log of x. Then what is du? What's the derivative? Just 1 over x dx. So let's see, what do I have? I have dx with 1 over x. That's du. Then I have this part is u. So the only thing that's in the way is that 3, and it's just a constant. So really what I have is du over u. Again, integrates as the natural log of the absolute value of u plus c. And what is u? The natural log of x. So yes, I have the natural log of the natural log. Looks weird, but that is correct. A couple of more examples. A little scarier. So one might be tempted to distribute that, and you could, but I don't think it would get you anywhere. What could you let u equal to? Let's try this. If I let u equal to 1 minus x to the 1/3, what's du? So that'd be negative 1/3 x. Then I'd subtract 1, and that'd be to the negative 2/3. So that's negative 1 over 3x to the 2/3. Oops, dx. Well, that's not terrible because now I have dx over x to the 2/3. So everything matches. I just need to take care of that negative. So if I multiply both sides by negative 3, So I now have, let's see, negative 3 du over u, which is negative 3 times the natural log of u plus c, and go back to what u equal to. It's kind of ugly, kind of weird, but not so bad. Number 8 is a definite integral. So after we integrate, we won't have a plus c, we'll actually have to evaluate that integral. And it looks kind of sweet and innocent, but we still have to use long division because we have an improper fraction. If the degree is the same or higher in the numerator, we need to do long division. So this integral becomes 1 minus 2 over x plus 1 dx. So again, 1 is very easy to integrate. That's just x evaluated between 0 and 1. And then hopefully you can now see, you can take out that 2. X plus 1 is your u, du is just dx. So this is just the natural log of x plus 1. And that is also evaluated between 0 and 1. So let's see, this is going to be 1 minus 0 minus 2 times the natural log of 2 minus 2 times the natural log of 1. So this is 1. This is minus 2 times the natural log of 2. And then, believe it or not, you should know that the natural log of 1 is equal to 0. So that is your final answer. So you really need to make sure that you've added this formula to your list of formulas you need to know for integration techniques.